is very much less as compared to previous semester. At least to it is because for B there will be the exams. For a T, ACT, I don't feel means online examinations, but for B there will be the certain some different patterns can be there. Don't know now depending upon the situation. Okay, fine. So we will start with the next session. So we have already started. The screen is visible. Yes or no?
No, ma'am. No.
Oh, I have not presented a screen. Now is it visible?
Yes, ma'am.
Okay, fine. So in previous lecture, we have started with the unit number 2, that is the models for regression and the classification. So in this particular unit, we are studying the different algorithms that we are going to use for the regression, means the prediction of any value for the variable, and the classification. So that we have started with. So the your contents, total contents are divided into different categories. First, it is related with the regression, and the second half it is related with the classification techniques. Okay, so in this we have started with the linear models for the regression. So your in this we are going to study the two different types of the regression model. One is the least squares and the second one is the nearest neighbors. Okay, so in previous lecture we have started with the least squares regression. Okay, so it means that how we can predict the value of any variable, any dependent variable, if the independent variable is given to you. Okay, and for that the method that we are going to use it is the least square. So how we have approached for this method that we have seen. So quickly we will take a review of this method. So we know that the in order to predict anything, we have seen a various real-time examples from predicting the prices for the house, number of burgers sold, number of the marks scored by a student depending upon the its number of study hours. So in these cases we are having generally the two variable, one is the independent and second one is the dependent variable. So our x is always we call it as an independent variable and y as the dependent variable, right? So y means the value that we want to predict, that we are taking as a dependent variable based on the one independent variable x. Okay, so for that we need to find. So what is our task? Our task is to find that regression line. Okay, regression line. So this line, suppose this is the line that we have to find out. So the equation of the line that always given by the y is equals to x plus c that we have seen. So in this case your m is always the slope and c is your y-intercept. So in this case we need to find out the value for the your m and c, and for that how to get that value of m and c in this least square method, we consider the loss function. Okay, so loss function, it is a measure of how different the predicted value is from the actual value. Means if it is asked us to predict something and we have predicted that value, so what is the difference between the actual value and the predicted value? So that is your error or the loss. So as a designer, what is our it is always a challenging to reduce that error. Okay, and in order to reduce that error or in order to calculate the loss, we always consider the loss function. Okay, so this is the loss function that we are taking. So in this, in order to minimize this loss, what we need to do, we always find the partial derivative. Okay, minimizing the function. Okay, so in this case we always find the partial derivative, we equate it to 0 and then we find the expressions for the m and c. So after doing this mathematics, the values for the m and c we get, that we have seen whatever you can see on this slide, that is the value formula for the m and the formula for the c. So here x bar or the y bar are the mean values for the x and y. Okay, and xi yi are the sample points for this for the given table. So once you calculate the M and C, then you can find out the you can draw that regression line, and for any unknown value of the x, you can find out the y. So it means that if you have M with you, if you have a C value with you, then for any value of the x you can find out y easily. So what is this y? This is our predicted value. Okay, so if this is the line with the given slope and the y-intercept, and for this random value of the x, what will be the y that is present on your this y-axis? So this is our prediction. Okay, this is our prediction. So we need to find out the means that be the with the least error or the minimum loss. Fine. So that is the regression line that we find with the help of these two values of the M and C. So in this case, we have seen this example also. Suppose this different data points are given for x, data points x and y are given. So we consider x as a number of x is the area in the square feet, or and y is the price of the house. So in this case, we can have the data for the analysis. So based on that data, we find out the equation for our regression line. Once we draw the regression line, then for any unknown value of the x, we can predict the y output. Okay, so with this, if you get the equation for the M and C, for any value of the x, you can find out the see, you can put the value of the x here for 2, 5, and 7, and you can find out the values for their y. So this is a kind of the prediction using the least square you can do. So in this, I can quickly show you the same implementation, one example with the help of the Python. Whether the screen is visible to you? Yes, whether the screen is visible?
Ma'am, you're showing Jupyter Notebook, right?
Yes, yes. Least square
Yes, ma'am.
regression. Okay. So here what we are doing, just simple example, whatever thing we have seen that we are just going to plot. Fine. So what we are doing, we are importing a different libraries. Here we need the NumPy, Pandas, okay, and Matplotlib to plot those graphs. Okay. So after that, what we are having a data in the one CSV file. Okay. So we are having one data in the CSV file. So that CSV file is here. G dot data. So the CSV means it is a comma separated value. So you can simply consider it is kind of a Excel file you are having. So here four columns are there: gender, age, head size, and the brain weight. So based on the gender with a different age range, and given is the head size in centimeter cube. Okay, what is the brain weight that is shown? So this is the data for the different gender and different age groups. Fine. So this is the existing data that we are going to use for our training data, for the training the machines. So in this case, suppose we can find out the relationship between this head size and the brain weight. Okay, so for that, what you can do, you can take our this as a x and this as a y. So if any unknown x is there, that is any unknown head size is given to you, you can easily predict the its brain weight. Okay, so for that, this is the database that we have taken in this case. So using the pandas, you can read that CSV file. So data is equals to pd.read underscore CSV. So that file, path of the file is given mentioned here. So I have stored it directly on the G drive. So data.csv, it is the name of the file. So with the help of this reads underscore CSV function of the pandas library, you are reading the that CSV file into your Python. Okay, and that is stored into the data. So what is this data? It is actually a data frame. So there will be the number of rows and number of columns will be there. Next, you are printing its shape, data.shape. So what is the shape function do? It gives you the number of rows and number of columns. So we know that there are 237 rows and the 4 columns are there. So that is the size of that particular database. Then we are printing the data dot head. So what is this head? With the help of the head function, you can just view the first five records of that database. So here you can see the first 5 rows are there, 0 to 4. So the what are the different values for the gender, age range, head size, and the brain weight you can show. In the same way, if you print data dot tell, then it will show you the last 5 records. So with this, just instead of printing all those, in order to get understand what are the different attributes or what are the different columns are there, you can simply visualize it with the help of the head function. Okay, then what you have to do, you can take that now out of this, I'm going to denote two columns. One is as x and another as a y. So what I'm doing, I'm taking x is nothing but the head size and y is nothing but my brain width. So what is the x is my independent variable, and y, that is the brain width, it is the dependent variable. Okay, so with this, from this data frame, the column name, head size and dot values. So you values of this particular column will form your x array, right? Values of your brain weight will form your y array. So here you are getting some x array and some y. X denotes your head size and y denotes your brain weight. Okay, so these are your x and y values. So for those x and y, what we are doing, we are printing here, like this is our x and this is our y. Okay, so in this case, the x and y data we have taken from some database. So next thing is we have to find out the value for m and c, that is the slope and the y-intercept. So for that we need to find out the mean of the x, mean of the y. So that we can do with the help of this numpy array. It has a one function mean. So np dot mean of the x, this will be your x bar. Np dot mean of the y, it will be your y bar. Okay, so we know the equations for the m and c, and gives you the total length of the x, that is the number of samples it can use. So how many the print n, that is the 237 different samples are there, and this is your 33633. This is your mean of the x, and this is your mean of the y. So the two different values, that is x bar and the y bar, we have calculated. Next, using the formula for m and c, you can find out the numerator and the denominator. So numerator, it is the x of I minus mean into yi minus y bar. Okay, so that formula we have seen. So the using those directly, you can write in terms of the for loop, because there are the number of samples are there, right? Xi means x1, x2, x3, in this way up to how many number of samples are there? 237 samples are there. Similarly, denominator formula you are calculating, and simply m is the numerator divided by denominator. Similarly, c value is the y bar minus m into x bar. And by putting the values, you will get the coefficients from m and c, like 0.2634, and the c is the 325. So this is the value of the m, and this is the value of your c. So we have calculated here m and c values. Okay, so using this m and c, and for different values of x and y, we are going to plot that regression line. Okay, so before that, what we are doing, we are simply plotting all those values of the head size and the brain weight here. Okay, so all these orange points that you can see is those are the head size and its respective brain weight. Okay, so for each of the point, that is for those 237 data points, we are plotting the head size versus the brain weight, and these indicates those points. Okay, and this green line, you can see the regression line that we have plotted based upon our values of m and c. Okay, based on our values of the m and c. So in this case, if any unknown x head sign is given to you, then what is its respective? Okay, what is its respective y, that is the brain weight that you can that will be available to you on this prediction line. Means for any unknown x value, its respective y will be in coordination of that green line. Okay, so you can see, means that actual value will actually reduce an error. So you can if you see the location of this regression line, then all the data points, those are equally located on both the sides of the line, right? Equally located on both the sides of the line. So if you consider the line, if you consider this line, some horizontal to the x-axis, then you can see quite underfitting will be there for that particular database. So approximately just by seeing the nature of this graph, you can understand the points of the database are equally located on the opposite sides of the that regression line. So whatever the predicted value will be there, it will give us the less error in the prediction. Okay, so this is the least square regression you can you can find. And in this, what is our objective? Our objective is simply drawing that regression line. And in order to draw that regression line, we must be able to find out the value of m and c. And how to find out the value of m and c? Based on the given formulas of that least square. And that for that we need the sample points as well as the mean or average values of the x and y. Okay, so this is the least squares regression. You can see the implementation in the Python. For that we have taken one sample database, and we have taken two columns of that particular database. So in short, what we are doing with this regression, we are finding out the relationship between the head size and the brain weight, and that is actually given through this graph or the scatter plots. So those initially the points are plotted, sample points are plotted, and based on our M and C, we have drawn that regression line for different values of the X and C. See here you can see line space, you are creating the different X array, and Y is nothing but our mx plus c. Here we have mentioned, we know the m value, we know the c value, and it will take the x values from this array. And for those array, you are plotting simply with the matplotlib. So the regression line and the scatter plot we are plotting, and this graph will be visible with the help of the plot dot show. Okay, so this is the regression, drawing the regression line or the linear regression with the least square method that we have seen. So in this, what we are doing actually, how we are predicting with the help of that particular regression line. So this is the way with which, this is the one algorithm with which you are predicting the value of any variable. So in this way, the another example that we are going to study, or another model of the regression that we are going to study, which is the nearest neighbor. Okay, which is the nearest neighbor. The name itself indicates nearest neighbor. So it is also known as the KNN. We call it as a K. K stands for the how many number of the neighbors you are going to consider in order to predict the values. Okay. So it is an algorithm used for the prediction of a continuous variable. It is a non-parametric, and it is a prediction problem. Okay. So now it takes a k nearest neighbor whose distances from that point are minimum and computes the average of those values. So how you are going to predict the value of a dependent variable using the nearest neighbor? Okay, that is now that we have to explore more. So this, as the this line indicates, it takes the k nearest neighbor whose distances from that new point are minimum. So distances means what? The distance means the it can be calculated with the help of a different ways. Okay, so that is the Euclidean distance, Manhattan distance, Minkowski distance. Okay, in addition to that, there can be the Hamming distance we can use for the categorical variable. So these are the different ways with which we can find out the distance between the 2 points. Okay, distance between the 2 points. So using these distances, how we can calculate the k nearest neighbors, that we will see. So now let's take an example. Okay, with the help of example, we will understand this. So here consider the table. It consists of the height, age, and the weight. Again, one database we are taking. I will just take it. Now you can see, consider the following table. It consists of the height, age, and weight. Same thing is given of a 10 people. ID 1 to 10 and 11 are there. Its respective height, age is given, and weight is given. And for 11 number ID, you can see it's his weight is height is 5.5, age is 38, and now our task is we want to predict its weight. Okay, so we want to predict its weight. So if it is a least squares method, then what you can do? If it is a least square method, so either you can take a height and the weight, or the age and the weight, and you can find out the relationship, and using that you can draw the regression line, and you can check whether that 38 age is there or the 5.5 height is there on that regression line. Its respective value on the y-axis will give you the weight. So that is the simple prediction. So in this case, using nearest neighbor, how we can find out the same. Okay. So now let's see how we can go proceed for this particular algorithm of the k nearest neighbor for the regression and not a classification. Okay. KNN is also used for the classification also. So in this case, we will see we have plotted the height versus age. Okay, we have plotted the height versus age. On x-axis we are having the age, and on y-axis we are having the height. Okay, this is the height and this is the age. So for the given points, these are the, you can say 297, these are the IDs mentioned. Okay, IDs of the people whose age and the height are mentioned here. So seventh number ID is having the height 5.3 and age 19. Okay, age is 19 and height is the 5.3. So that is the data point of the seventh number ID. So in this way, we have plotted the graph of the age versus height for all those 10 people. Okay, and here you can see the 11th people is there. Okay, 11 number people, 11 number ID is there. So from this graph, okay, from this graph, if I want to predict, the weight of the 11 number ID, okay, 11 number ID, then what we can say, we can see the which data points are closer to this 11 number ID. So we can just visually roughly we can see, we can say that this 6 number as well as this 5 number are close to 11, right? So based on that, what we can consider, we can consider that the weight of the ID number 11 can be approximately equal to the weight of the 6 number or the 5 number, right? So 6 number or the 5 number. So if you see the 6 number and the 5 number, so it is a 60 and the 72 is there. 60 and the 72 is there. Also 1 is there, so 1's weight is the 77. So we can roughly estimate that the weight of this ID number 11 will be close to the weight of the ID number 6 or the ID number 5, or whichever is the closer to 11, right? Whichever is the closer to 11. So in this case, what we need to find for this new ID, that is the ID number 11, we need to find out its distance from remaining all the data samples. Okay, so in order to do the that KNN algorithm always uses the feature similarity to predict the values of the new data points. Okay, and for that you can see for this new ID, which is shown with the yellow color, that's why means it will not be that properly visible for all of you. So this is actually shown with the yellow color. Okay, so this is my ID number 11's age, and the height is mentioned here. So accordingly its location comes here. So from this point, what we are doing, we are calculating the distance between this point and the 6 number. So all the distance between all the points we are calculating. Okay, so how we are calculating the distance, that initially as we have seen, the distance is calculated in terms of that Euclidean distance. So there are different distance measures that you can use. Okay, so once you find out the distance of that new data points from the existing data point, then after that we have to choose the closest k data points. Okay, closest k data points. So what is the k in this case? So k can be either 1, 2, 3. So how many data points we are considering? So I can see that I'm considering the three nearest point, okay, whose distance is less. So here k 3 points I'm consider means my value of the k is 3. If you are considering the 5 such a closest point, so your k value will be 5. So in such a way, how many number of neighbors which are closer to that new data point you are considering, that denotes the value of the k. Okay, that's why we call it as a k nearest neighbor algorithm. Fine. So here if you take the value of the k is a 3, so you are going to choose the distance of the you are going to choose 3 data points which are closer from that new id. Okay, which are closer from that new id. So in this way you are calculating the closest distance, and based on that, now in this case you can see the 6 number is closer, 5 number is closer, and 1 is closer. So these 3 data points you have considered. So what will be the weight of the new id? That is nothing but the average of weight of 6 weight of 5 and weight of 1. So at average of all these three, 77, 72, and the 60 divided by 3. So average weight of all these three will be the predicted weight of the ID 11. So we can say 69.66 kg will be the weight of your this one. Okay, here question mark is given. So that will be your predicted weight for this ID number 11. And how we have calculated? It is taken the average weight of 77, 72, and the 60. Why we have considered only 1, 5, and 6? Because the distance of these 3 data points from this 11 number data point is closer. Okay, or it is a minimum. That's why we are considering the weight of only these 3 points. Fine. So with this we are calculating. So how we can calculating a distance? For that the formulas are shown. See, these are the formulas for the Euclidean distance, Manhattan distance, and the Hamming distance. So here the formula is given. It is the square root of the summation I is equals to 1 to k xi minus yi bracket square. So what is your k? K is the number of points. How many number of points you are considering here? So xi minus yi. So in this case you are taking the subtraction for those values, and you are simply adding each of these. So here x and y will be, x and y is nothing but your these. Suppose you can consider this is your x and this is your y. So in order to calculate this calculate the different values, not this will be y. Suppose you have to calculate the distance of this 11 and the 1. 11 and the 1. So what you can do, 5.5 minus 5, okay, plus 38 minus 45, and you are taking a square. Why? Because sometimes it will be a negative, so square of that will be a positive only. And in this way you are calculating the distance, so you can add one more column of the distance here. Once you calculate the distance of each of the point from this 11 number id, okay, 11 number id. So here you will note down the distance using those formula, any of the formula, and out of these distances you are going to choose. If you have selected the k is equals to 3, then you will choose the 3 smallest distances. Okay, so as per our calculations, in this case we are getting the minimum distance for though this id1, id5, and id6. So once we get these data points, then their values of the weight, we will take their average, and that will be the new predicted value for the for this new data set or the id 11. Okay, so here in this case we have calculated that values to be 69.66 for the id number 11. So this is the way with which your KNN, that is the K nearest neighbor algorithm, work. In case of the least square, we need to find out the values of M and C. We need to get the regression line, and then you can find out the value for the predicted value. Here you need to get the minimum distance between the out of all those data points, and simply you can take the average weight, and that will be the predicted weight for your ID number 11. Okay. Now here, how to choose the K factor. Now in this case, that means based on the trial and the errors, depending upon the application, you can have the different values of, or you can settle with the one of the values of the K. So we can't means say for all the cases the k equal to 3 is the best choice, or k is equals to 9 will be the best choice. So for that, what you need to do, you need to find out the validation error curve for each of these applications or the regression, and based on that you can find out which values of the k your validation error curve reaches the minimum, and based on that you can identify the value of the k will be best suited for your prediction or the regression, and that we can actually call it as from the elbow curve. You can easily find out the what value of the k you need to select in order to calculate or in order to predict the value for your variable, or that is the dependent variable. Okay. So this is the nothing but the KNN, that is the nearest K nearest neighbor algorithm, which is used for the linear regression. So till now we have only considered the linear regression only. Okay, so linear means there is a linear relationship between x and y, means if you increase the x, y will also increase. So such a kind of the functions you can model with the help of those least square as well as the knn. But this is not the case that always your function is a linear only. Sometimes it can show the non-linear nature also. So in that case, how we can go with the how we can achieve with that non-linearity, and for that we actually go with the linear basis function models. Okay. So how we can do that particular thing? In this case, the basic linear model for the regression is a model that involves a linear combination of the input variable. Means in our case, suppose equation of y we always consider it is the f of x, right? F of x. So that predicted value that you can calculate with the help of the function of x. So a simple form of the function we have seen, it is nothing but the mx plus c, right? Mx plus c. So this is the one commonly used f of x. So in this, as we call it as a linear function, so it is the linear combination of its input variables. So if your x, that is the independent variable, is more than one, okay, it is more than one, so in that case you can consider the linear combination of those independent variables. So here w0 plus w1 x1 plus w2 x2 w3 xt. So here w, it is the weight of that particular weight of that particular input variable x1 x2. Okay, so where x is the combination of x1 x2, so these are the different parameters or the different independent variables on which our prediction depends. Okay, so this is a linear regression, and the key attributes of this function is that a linear function of the parameters w1, it is the linear in the w also, and it is a linear function of the input variable x. Fine. So in this case particularly, means for a given set of the input data set of n samples. Okay, in our case in practicals we have seen the previous database that we have seen, the data.csv, it was having some 237 data lines, okay, rows. So what are those many samples are there, right? So those n samples means now in this case there will be the 237 different samples are there. So, and as well as we will have its corresponding target values. Target means the value that we want to predict. Fine. So the problem is to deduce the value of the t for a new value of x. That we always do in case of the linear regression. So here the set of the input data set together with the corresponding target, it is known as the training data set that we use to train our machine. So on way to handle this is by constructing a function y of x that maps x to t, right? So this is nothing but our y is equals to f of x that I have already told you. So that is our regression problem. But what is the problem with this linear model? So being a linear function limits the usefulness of the function, because most of the observation that may be encountered does not necessarily follow the linear relationship. So this is the case, means we have seen the linear models for the least square to predict something, also KNN, but it is not the case that always there will the nature of, between the two variable is linear. Okay, sometimes there can be the non-linear structure also. So to solve this problem, we need to modify the model to be a combination of fixed nonlinear functions of the input variables. Okay, so in order to follow the nonlinearity, or in order to consider the nonlinearity between the two variables, we need to modify our model, and for that we add some basis functions in our linear model to make it as a non-linear model. Okay, so if we assume the non-linear function of input variable phi x, then we can rewrite the original function as, so we have written y of x w0 plus w1 into phi of x1. So instead of that, see you here you have seen the we write w1 x1. So instead of w1 x1, we are writing the input as a function of those basis function. Okay, so phi of x1, phi of x2, phi of xd. So summing it up, we can write y of xw is equals to w0. It is the bias, so which is a constant, plus summation j is equals to number of sample points. Okay, wj phi of j plus. So here phi of x are known as the basis function. So what is the significance of this basis function? So what we are doing, why it is necessary to go with such a kind of the modified equations for this? So sometimes we need to model the non-linearity between the two variables. So in order to accommodate it, we modify the linear regression using this basis functions. Okay, and how that changes. So in this case, our W0 into 1 here, the multiplication factor is actually 1. That's why we only see the W0, W1 into X1, W2 into X2. So in this way, we write the weights or the parameters of the model, and Xi is the independent variables, and Y is the approximated value for the dependent variables. So these basis function actually, those are the linearly combined set of the simple functions of those independent variables. Okay, and it's called as the basis sets. Fine, so here you can see instead of that xi, what we are replacing here, that is the phi 1 of x, phi 2 of x, phi 0 of x. So that is that we are writing down its respective basis function. Phi j of x is called a jth basis function, and w0 works as a bias, means what, due to this bias your regression line will be shifted on the x-axis. Okay, so from this, if you add the bias, that will be added into your line, and that line will get shifted on the x-axis, and that is the significance of adding this bias into your basis function. Fine. So the next part of your bias variance decomposition, and the next the Bayesian regression. We have seen the linear, non-linear. Now the Bayesian regression, how it performs, that we will see in the next class. Okay. So today we will stop here. Only 16 students are there right now in the meeting. Very poor attendance.